Hello everyone, my name is Abhishek Bansal. In this video I am going to talk on the course, or rather I am going to talk on the magnetic course. So we know that we have just seen that we need a magnetic field, or we need a magnetic flux that is going to get created when the current is going to pass through this coiled wire. Okay, so the ability to control this magnetic field or the magnetic flux is very critical here in controlling the operation of the magnetic device. And we know what is basically permeability. In a simple word, the permeability is an ability of the material to conduct the magnetic flux. Okay, so the main purpose of the core is to contain the, when I am putting a magnetic or some ferrite core here, the main purpose of this core is basically to confine the magnetic or to contain the magnetic flux and to create a well-defined, we have a well-defined predictable mean path length here. And so what are basically the core types? So we have basically have two type of magnetic cores in the construction. Or we have basically two types of construction for the magnetic cores. One, we are having a shell type. In the shell type, we basically see the shell type is basically let me now draw properly a square. So this is a shell type construction here. In this, you can see in this shell type construction we have a flux phi, and the flux is basically across this way. If I am going to say this is the flux, if I am going to say, take a different color, this is the flux if I am going to say, and this is the inside is the coil here. So we can say the core surrounds the coil. So this is the shell type. The another is known as the core type. In the core type, there are basically two types of construction in the core. One is the shell and the another the core. So in the core type, here the core surrounds the coil. Okay, here this is not a here we don't have any winding here. Here the coil is not here, but in the core type the coil is surrounding the core. So here we are going to see the coil would be here, and we can have another construction where the coil gets surrounded by the core. Okay, so what effect is going to produce a magnetic field is that if I am going to use this shell type, the magnetic flux, the magnetic fields, they are around the outside of the coil, and the advantage is that it requires only one coil. Whereas in the core type of construction, the coils are outside the core. You can see now we are having here outside of the core. Okay, this example would include a we know in the toroid. Okay, now what are the basically type of core materials? I have talked on the construction of the core. Now what is basically the type of core materials? We have basically three kind of core materials. One is the bulk material, the bulk metal, and the second is the powdered material, and the third is the ferrite material. So when basically the bulk metals have a very these are not very simple processes, because like for if we want to create a magnetic core using the bulk metal, we are going to process it from the furnace into ingots, and the material is then going to put in the process of cold and hot and the cold rolling. Okay, so that's how the bulk metals are rolled according to the required thickness. That could be, let's say, 0.0 0.002 inches to, let's say, to the more minute I can say. Okay, I have drawn here into 2 into 10 to the power minus 3 inches. I can say 2 into 10 to the power minus, this is negative, minus 6 inches. So in the powdered, now let's go on the second material. Let's say powder material. In the powder material we can have a powdered molymer alloy, and we can have a powdered iron materials also. They are basically pressed, or basically they are die pressed into the torites or an EE cores and the slugs. So the powdered core process also use of the ingots. Okay, and the last is basically I am going to use the core materials, the ferrite material. The ferrite is basically a ceramic material of an iron oxide. It's alloyed with an oxide or the carbonate of the manganese, zinc, nickel, magnesium, cobalt. Okay, so these are basically our main materials that we can use it. I have defined the main materials. Now we can have a like we can have a toroidal cores, or if I am going to talk on the there are very different kind of toroidal cores also, like a tape toroidal core, or we are having a tape bond C or a tape bond double E or EE cores. We also then consider what are basically the stacking factor and window utilization. Okay, so I am going to go into actually I don't have made any notes, so toroidal per core. So one thing what you should know, that this toroidal powder core, if we are going to use a toroidal power core, they have an inbuilt air gap, and these are stable with time and temperature. This has to be stable with time and temperature. So when we are basically designing a transformer, we come across that I make a difference. We definitely I have mentioned approximately 30 cores in my this self-claimed some method, which was basically limited to a particular wattage and then voltage only. So you can see the list of the 30 cores are there, and there are more than that. There can be more variants in that, and even what this in this contest we have given an SP core in the gate drive transformer also. So in this core I am going to close it because it's basically it needs a table that I am not showing here.